Hello, my beautiful viewers. You're welcome to my YouTube channel, Mathematics Made Easy. So, yeah, you're welcome to my YouTube channel, Mathematics Made Easy. So, in today's video, we'll be solving this beautiful problem. Says given that the zeta of 2k equals summation of n from 1 to infinity of 1 over n raised to the power of 2k, which is equal to minus 1 raised to the power of k plus 1, multiplied by the Bernoulli number, multiplied by 2 pi raised to the power of 2k over 2 multiplied by 2k factorial. So the problem says, hence use the expression above to solve the Basel problem. Yeah. So that's beautiful. Okay guys, before we dive into the solution, please, if you are new in this channel, please don't forget to subscribe to my channel, like my videos, comment, and share. Thanks guys for watching. Alright, so now let's start the solution. Now when we're talking about the Basel problem, and here's the Basel problem, it says 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared, then plus dot dot dot. So that's the Basel problem. So then how can we use this given expression to solve this Basel problem? So this 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared. So this is equal to the sum of n from 1 to infinity of 1 over n raised to the power of 2. Okay, that is so beautiful. Then check this expression given to us. This is zeta of 2k. So that shows that this is also equal to what? The zeta of 2. That is when k is equal to 1. So we have the what? We have the Basel problem. That is so beautiful. That is, if you substitute k to be 1 here, you're going to have summation of n from 1 to infinity of 1 over n squared. So which is also equal to minus 1 raised to the power of 1 plus 1 multiplied by the Bernoulli number. Then if we substitute k here, so we have b of 2, then multiplied by 2 pi raised to the power of 2 multiplied by 2 over 2 multiplied by 2 multiplied by 2 factorial. Okay guys, so let's just dive into the solution. Yeah. So to solve for the Basel problem, for the Basel problem, k must be equal to 1, okay? So at k is equal to 1, we're going to have the solution to the Basel problem. So let's do that. So the zeta of 2 will be equal to minus 1 raised to the power of 1 plus 1 multiplied by the Bernoulli number. So when k is equal to 1, multiplied by 2 pi, then raised to the power of 2 multiplied by 1, then everything over 2 multiplied by 2 multiplied by 1 factorial. Yeah, so this will be equal to, 1 plus 1, that will give us 2. So we're going to have minus 1 raised to the power of 2 multiplied by b of 2, 2 times 1, that is 2. Then multiplied by 2 pi raised to the power of 2, because 2 multiplied by 1 will give us 2. Then everything over 2, then multiplied by 2 factorial, 2 times 1, that will give us 2 factorial. Okay, so moving on, we're going to have the zeta of 2 equals, so minus 1 squared, that is just 1. Then multiplied by a Bernoulli number, then 2 pi raised to the power of 2, that will give us 4 pi squared. And everything over, don't forget 2 factorial, that will be equal to 2 times 1, which is equal to 2. So 2 factorial will give us 2, then multiply by 2, so that will surely give us 4. Then, if we cancel out this 4, so we're going to have this beautiful value, b2 multiplied by pi squared. Yeah, so you'll be wondering how to find this b of 2. So that is where the problem lies. How are we going to find the Bernoulli number when n is equal to 2? So I'm going to write out the formula that we're going to use to find this Bernoulli number. So let's do that. So let's write this somewhere. Yeah. So we're going to find b2 of pi. Alright, so that is what we want to find. So let me just clean these parts. Okay, so we are almost done, guys. I'm sure you are learning new things today, and I'm sure you are with your book and pen, so make sure you jot some things down. So here's the Bernoulli number. So b of n equals summation of k from 0 to n of minus 1 raised to the power of k multiplied by k factorial over k plus 1 then multiplied by the Stirling number n comma k. Beautiful. So we have this beautiful formula to know b of 2. So in this case, n will be equal to 2. That is, when n is equal to 2, we're going to have, just write like this, we're going to have, let me put here, we're going to have b of 2 equals summation of k from 0 to 2, then of minus 1 raised to the power of k factorial over k plus 1 s, so you know n is 2, that will be 2 comma k. That's beautiful. So let us sum this function from 0 to 2. So we sum this function from 0 to 2, we are going to have minus 1 raised to the power of 0, that is when k is 0, multiplied by 0 factorial over 0 plus 1, s of 2 comma 0. Okay, so plus when k is 1, we're going to have minus 1 raised to the power of 1, multiplied by 1 factorial over 1 plus 1, multiplied by s of 2 comma 1. Okay, plus when k is 2, we're going to have minus 1 raised to the power of 2, multiplied by 2 factorial over 2 plus 1, multiplied by s of 2 comma 2. Yeah, so that's what we are going to have. Okay, so if you simplify this completely, we're going to have b of 2 equals, so minus 1 raised to the power of 0, so that should give us 1. And 0 factorial, that is 1. 0 plus 1, that is 1. So 1 multiplied by s of 2 comma 0, so we're going to have s of 2 comma 0. Then minus 1 raised to the power of 1, so that will give us negative 1. So we have minus 1 factorial, that is 1, over 1 plus 1, which is 2. Then multiplied by s of 2 comma 1. Then minus 1 squared, that will give us 1, okay? So plus, so 2 factorial, that is 2 times 1, which will give us 2. Over 2 plus 1, that will give us 3. Then multiplied by s of 2 comma 2. Wow, so this is another problem right here. So that is how to find s of 2 comma 0, s of 2 comma 1, and s of 2 comma 2. Okay, so let me clean this part. Yeah, so that is, let me just write this up. So if I write this up, so that is we want to find b of 2, which is s of 2 comma 0 minus 1 over 2 s of 2 comma 1, then plus 2 over 3 s of 2 comma 2. So yeah, we can now clean this. Okay guys, so for us to know the Bernoulli number here, we have to find these Stirling numbers. Yeah, it also has a formula. It has a formula that we're going to use to find the Stirling number. So now here is the formula. We know that s of n comma k, so that's the Stirling number of the second kind, which is equal to 1 over k factorial, then multiplied by sum of j from 0 to k, then of minus 1 raised to the power of k minus j, then multiplied by k combination j multiplied by j raised to the power of n. So that is the Stirling formula. Yeah, that is beautiful. That is beautiful. So guys, let's move on. So let's find this one after the other. So now let's find s of 2 comma 0. In this case, n will be 2 and k will be 0. So we're going to have 1 over 0 factorial, then multiply by sum of j from 0 to 0, minus 1 raised to the power of 0 minus j, then 0 combination j, then multiply by j raised to the power of 2, you know, n is 2. Yeah, so 0 factorial, that will give us 1, so 1 over 1 is just 1. So this will be equal to sum of j from 0 to 0 of minus 1 raised to the power of negative j, you know, 0 minus j, that will give us negative j, then multiply by 0, combination j, then multiply by j raised to the power of 2. Yeah, so now let's find this value. So let's just sum this from 0 to 0. So if we sum this from 0 to 0, that is, you set j to be 0. So we're going to have minus 1 raised to the power of minus 0, multiplied by 0 combination 0, then multiplied by 0 squared. This will then give us 0 because it's multiplying with 0. So we're going to have 0. That's beautiful. Okay, so that is S2 of 0. So S2 of 0 equals 0. We are done with this. We have 0. So it remains S2 of 1. So now let's find S2 of 1. You can pause the video and try and find S2 of 1 using the same pattern I used. Okay? So we are done. Yeah, you can play it back and check whether you're correct or not. Okay, now let's find S2 of 1. I mean S2, 1. So in this case, N will be 2 and K will be 1. Okay, so this will be equal to 1 over 1 factorial then multiplied by sum of j from 0 to 1 of minus 1 raised to the power of 1 minus j. Okay, so that will be 1 combination j and j raised to the power of 2. Yeah, that's beautiful. Okay, guys. So this will be equal to, so 1 factorial is 1, 1 over 1, that is just 1. So we're going to have sum of j and from 0 to 1 of minus 1 raised to the power of 1 minus j and of 1 combination j raised to the power of 2. So how do we solve this? Let's just sum this j from 0 to 1. Okay? So when j is equal to 0, we're going to have s2, 1 will be equal to minus 1 raised to the power of 1 minus 0, then 1 combination 0, 0 squared. Plus when j equals 1, we're going to have minus 1 raised to the power of 1 minus 1, multiplied by 1 combination 1, multiplied by what? 1 raised to the power of 2. And this will give us, you know, this part will surely give us 0. That should give us 0. So this will be equal to minus 1 raised to the power of 0, 1 combination 1, then 1 squared. So minus 1 raised to the power of 0, that's 1. Then 1 combination 1, what is 1 combination 1? So let me quickly write the formula. If you have n combination k, this will give us n factorial over k factorial multiplied by n minus k factorial. Okay? So if you use this idea to find 1 combination 1, you're going to get 1. You can try it. So this will give us 1. That is beautiful. Because minus 1 raised to the power of 0, that is 1. 1 combination 1, that is 1. 1 squared, that is 1. Okay? So that shows this s of 2, 1 will surely give us 1. Beautiful. So this is 1. So the last one is s of 2, 2. That's what we want to find. Yeah, you can also pause and try it if you get it. So let's check. Let's check. S of 2, 2. S of 2, 2. Okay, so are you done? Okay, see what we get here. So s of 2, 2. So in this case, n will be 2 and k will be 2. Yeah, so this will be equal to 1 over 2 factorial, then multiplied by sum of j from 0 to 2, then multiplied by minus 1 raised to the power of 2 minus j, then 2 combination j, then j raised to the power of 2. Okay, guys, so now let's move on. So this will be equal to, now 2 factorial, that is 2 times 1, that's going to give us 2. So we have 1 over 2, then multiplied by sum of j from 0 to 2 of minus 1 raised to the power of 2 minus j, then 2 combination j raised to the power of 2. So now let's sum this from 0 to 2. Okay? So we're going to have s of 2, 2 equals, so when j is 0, so we're going to have 1 over 2, then multiplied by minus 1 raised to the power of 2 minus 0, then 2 combination 0 multiplied by 0 raised to the power of 2. Then plus when j is 1, we're going to have minus 1 raised to the power of 2 minus 1, 2 combination 1 raised to the power of 2. And when j is 2, we're going to have minus 1 raised to the power of 2 minus 2 multiplied by 2 combination 2 multiplied by 2 raised to the power of 2. Yeah, so this will be equal to 1 over 2. Now definitely this first part will be 0 since it's multiplying 0 right here. So we're going to have 0. Okay, so what is 2 combination 1? And before that, 2 minus 1, that will give us 1. So minus 1 raised to the power of 1, that is minus. So we have minus. So what is 2 combination 1? So if we make use of this formula, 2 combination 1, that should actually give us 2. Now let's check. So that will be 2 factorial over 1 factorial, 2 minus 1 factorial. So that will be 2 factorial over 1 factorial, 1 factorial. That is 2. Okay, so 2 combination 1 will give us 2. That's beautiful. Then 2 minus 2, that is 0. So we're going to have plus, but because 1 raised to the power of 0 will give us, negative 1 raised to the power of 0 will give us 1. Now, what is 2 combination 2? If you make use of this, 2 combination 2 will give 1. You can try it. You can try it. So that will be 1 multiplied by 2 squared. So don't forget 2 squared will give us what? 4. 2 times 2, that is 4. So the 2 combination 2 is 1. So we're going to have plus 4. So this will be equal to 1 over 2, then multiply by 2, and this will surely give us 1. That is beautiful, because minus 2 plus 4 will give us 2, then multiply by 1 over 2, we will have 1. So that shows that s of 2, 2 is 1. That is wow. Okay guys, since we have the values of the Stirling numbers, so we're going to find the Bernoulli number when n is 2. So guys, let's find the Bernoulli number now when n is 2. B of 2 will be equal to, s of 2, 0 minus 1 over 2, s of 2, 1 plus 2 over 3, s of 2, 2. So we have s of 2, 0 to be 0. So that will be 0, then minus 1 over 2, then s of 2, 1 to be 1, then plus 2 over 3, then s of 2, 2 to be 1. So this will give us 0 minus 1 over 2 plus 2 over 3. And that should give us, the LCM will be 6, and this one just remove the 0. So 2 in 6, that is 3. Then multiply by minus 1, we're going to have minus 3, plus 6, 3, 6, that is 2, multiply by 2, we're going to have 4. So that will give us 1 over 6. That is beautiful. Hence, B of 2 is 1 over 6. That is the Bernoulli number we're looking for, 6. So we have 1 over 6. And don't forget that zeta of 2 is what? B of 2 multiplied by pi. And that is beautiful. We have the value of B of 2, which is what? 1 over 6. Then we have 1 over 6 multiplied by pi, and that's going to give us, pi squared. I forgot to put the square. My bad. So we're going to have pi squared over 6. That is beautiful. Okay guys, so if you like this kind of video, please don't forget to subscribe to my channel, like my videos, comment, and share. So see you next time. Bye.